Hello everyone, it's Bradley. So today this is a tutorial talking about the stylized nuclear explosion effect I've made previously. Initially, I was intended to replicate a VFX that people created in Unity, but later I gave up because to create a good animation, you always need to concern so many details and you have to repeat a lot of works. So I give up because I do not want to deal with whatsoever. In this tutorial, I neither want to discuss every details aspect within the animation, but we will see how far we can actually go through in the simplest manner. So let's start. As always, I'm going to use the presets I created for myself, so you can download them for free from the link in the description. Okay, so within geometrynodes, there is no torus. I don't know why, but probably because there's easier way to create that. So we have to create a torus by our own. Basically start with a curved circle. And let's take a bevel curve. Ta-da! Immediately we have a torus. So let's just increase the resolution. So this is a donut that we start to have. Okay, which is kind of very cool. But we're going to talk about the basic part. So there are three parts of the nuclear explosion. The first part is the ground part. The ground part is probably the most difficult part. But if you really think about it, it's actually astonishingly easy. So basically what we do is we try to displace it. But usually I'm displacing everything with noise texture, which turns out to be noise 3D. In this case, we're going to use a different texture, which is actually Voronoi. So we take a Voronoi 3D. So this is also a new preset. And okay, I'm not going to use the setup position. I'm going to use the normal displacement, so that we displace upon normal. So again, actually, all this kind of principle comes from how people do within modifier. So there's, technically speaking, nothing really new. It's just move all this kind of modifier work into the nodes. And basically that's the idea. And once we have this Voronoi and it looks kind of very ugly, it's simply because there is not enough subdivision. So let's increase the subdivision and we get this kind of result. It looks much kind of spiky instead of, I don't know what to tell. So this is very kind of cool. So we just decrease, not the evolution, we just decrease the frequency. So now it looks kind of blobby, like whatever. But you still always realize all this kind of Voronoi texture is kind of very pointy. So this is not very good. And to make it not pointy, you need to run through a kind of a horrible, weird math with all this kind of multiply, subtract, the square root, and so on and so forth. And that's why I made this into a preset, so that you just hit this box, it becomes rounded. That's why I made this preset. So overall, this is giving kind of effect like we have different sphere, and they're being put with a remesh modifier or something like that. But in reality, it's really just a torus being displaced with Voronoi. Okay, and to animate that, we just take a translate position node and plug that into vector. And let's take a time info node and plug onto the z-axis. So let's play this animation. Make it just 300. And it's going downwards. So let's take a negative. So it goes upwards. Something like that. So you can control the rate. Maybe 80. So you get a sort of ideas. But up to now, there is not enough details yet. So you can take another normal displacement. And you can even take the Voronoi 3D. But this time we're going to take the frequency a little bit more. So the more kind of group like, but we're going to decrease the scale. Something like that. Just creates a little bit irregularity on the surface. Or you can even use the noise texture. Who knows what you are going to do. but just getting kind of idea should be good enough, because at the end this will just be shaded with whatever, so that you won't really see every part of details. As long as you get rough shape right, it should be okay. So this is the bottom part. One very interesting thing is if you're changing the radius, then you can see this animation. Okay, but there's definitely a kind of issue because we're beveling the curve, adding the thickness to the curve. Then if there is zero radius, it will cause this artifact. So here there are several things that we can try to deal with it. I think the easiest way, let's just take a group input, and we're going to use just add a value, and we're going to set the minimum and maximum as 0 to 1, and plug that into the radius. Here, let's take a switch node and plug these values into the switch. So if this value has any value, then it will output true. This is the concept of a switch, or actually the concept of Boolean. We're going to use these inputs in many other places. So for the moment, I'm just going to take a math to multiply if we want to increase more value. And I'm going to decrease the radius a little bit. So now by manipulating this input, we are having this ground part. Okay, so this is good. Next, you need to think about whether you want to keep continuing within these same objects so that you join everything using a join geometry, or you create a completely different object with a completely different tree. And such kind of decision will make things very kind of different later when you're working. But I guess I'm going to continue within the same tree, just to know that it may not be always ideal to work within the same tree. Okay. So we start from scratch from other things. And basically the second middle part is the same as the tornado animation I created. So you start with a curved linear, not centered, and make that looking at the axis. Here we may use the stop mode. Okay, so let's take a bevel curve, and let's take a set curve radius. Here let's take a curve parameter, float curve. So something like this, and we definitely need a map range. I think we start to be thick and then try to decrease its scale. So now if we increase that, so this is kind of tornado part that we get. So let's increase the resolution like 16. And let's join geometry so we can see the effect. So you need to tweak some values like the height and other parts. And definitely all this kind of value needs corresponds to the geometry that we have. So let's just duplicate these group inputs. Here, let's take a math node. No, actually, this is tricky. I guess, I don't know. Take a math node. Because knowing that this input always goes from 0 to 1. So just multiply these values. And if you animate that, this is what you get. Okay. And again, we have this effect that's When it's 0, then it's just being crushed completely. So you can do almost the same trick. It's just an option. It's not necessarily say, oh, you must do this. It's just a way. Or else what you can think is plug these values to map range and so on and so forth. There are tons of ways to think about this. So let's plug this into the radius. Probably not a very good idea. Let's plug times that's 0.2 and see the ET effect. Something like that. You can tweak more. Do I still need this switch? Probably I no longer need this switch anymore. So these are just the different ways to solve the problem. And you can definitely add the noise on the top of this guy. It's the same methods. You use the noise displacement, noise texture over annoy. But I probably will not add anything at this moment. So let's move on to the third part. The top part is kind of very tricky because the shape looks like this shape, and it's kind of not very intuitive to create. People suggest me to use math formula because this is a shape which is kind of like a heart. Actually, this is a kind of kidney shape. But I do not want to deal with the math formula. I neither think you will be interested in that as well. So we're going to use a kind of Dumbo method, but it's kind of effective. So let's start with a, no, not a UV sphere. Let's start with an icosphere. The reason I like icosphere is because it's kind of very uniform. And you increase the subdivision, then it becomes as round as a UV sphere. Okay. And we're going to set a position. So previously we were talking about the kidney shape. So considering the fact that if we're using a transform and we just shrink it, then a similar kind of kidney shape despite the fact that there is no indentation at the bottom. So to make the indentation, we need to use a directional fold or proximity fold. But I think a directional fold functions better here. So let's plug this combine XYZ, and we can plug this fold into place, and immediately we can see any effect because currently we're working on the X mode. So let's work on the Z mode. So by changing this directional offset, then we can see how it's actually changing the effects on our mesh, and we can try to play around this minimum and maximum so that changing the value of indentation. We can also increase this scale offset so that it becomes softer of its effect. So this is kind of idea. And if we increase, actually decrease, and now you can actually see this indentation, and it's definitely affected by our scale offset and our maximum value. So finally you get some sort of this kind of result. With this result being given, we can add a subdivision surface later so that smooths out some hard edges that we cannot deal with. So something like that, then it works fine. Here you realize there is a relationship between the radius and the direction. So we take a negative so that we have the negative value for the direction offsets and the positive value for the radius. Because we're going to animate the top part as well, so we still use the same inputs into the origin. So that as we are animating the bottom parts, we can actually scale our top part as well. Okay. So here we can combine all this kind of geometry together. But you can see our top part is staying at the ground. That's why I need this transform node. So let's take a combine XYZ. You actually need to know that the top part is basically the top part of our middle part. And you can see this effect, like a mushroom cloud. And you try to play around these values. So this is kind of basic idea. And what to do next? You definitely need to add more kind of noise on the top part as well. So basically do exactly the same. So take a normal displacement and a normal displacement. Here, we still need to use the Voronoi 3D. Add some blobness. Decrease the frequency. Add some rounding. And for the second normal displacement, we add some details using whichever you want. Noise texture or noise texture. It's your decision. So after everything, let's just take a set shade smooth to smooth everything out in shader. Also, we need to change a little bit about the values, something like that. As long as you get generally correct, it should be fine. Up to now, we have finished the basic part of this animation. It may not look kind of too horrible with the usage of all these kind of presets, but in reality, it's still kind of very horrible even using these presets, because there are so many settings that you have to tweak. It doesn't just end here. For example, we still need the animation within this kind of Voronoi texture. So now if you try to play this animation, the bottom part should be animated. It's not very clear. The reason, I think, is because we didn't plug this translated position into the custom vector. So now you can see the blob parts of the button is actually move upwards, like the smoke is rising, which is very, very good. But if you think about the upper part, then all this kind of blobbing part actually should move downwards. So we need to have a different translated position. We also need to have a different time info node. So plug that to vector z and plug that to vector. So now you can see the opposite movements. Definitely we need to actually switch the parameters like 60 or something like that. So this is kind of idea. Okay. That's why I actually do not use the exact same setting, because I need a different setting. So this is the tricky part. And of course, as the time goes, you have to add a lot more settings on the top of that, taking more and more nodes and so on and so forth. So this is just a kind of a simplified setup. Okay. In this tutorial, I'm not going to talk about the UV. Maybe it will be in part 2 if I were to make one. But basically the idea is, because these are geometry created within geometry nodes, so you have to add a material using set material node. And instead of using a single material, I'm going to add 3 separate material in 3 sockets, because their UV map and noise texture aren't the same. So these are 2 curve mesh. This one, what's this one? Yes, this one has its own UV map. Also, the animation direction is still different, as I've mentioned earlier. So there are lots of differences. You have to manage each shader individually. There are all sorts of issues also talking about the outputting data in the group output. So it's kind of a complicated story, but I think for this part of the tutorial, I will just stop here. So I hope you enjoyed this tutorial. I'll probably see you next time. Bye-bye.